All right, so let's work a second order differential equation. This is homogeneous because it all equals 0. So we're going to try the solution y equals e to the rx, because that tends to be our solution for these kinds of second order homogeneous equations. All right, so I'm going to plug that guy in, and so I should get r squared times e to the rx. All right, just taking the derivative of that twice, I get the r squared in front of the e to the rx. All right, then plus 6 times taking the first derivative, I get r e to the rx, plus 9 of just the y, so 9e to the rx. That all equals 0. So I'll go ahead and factor out an e to the rx, right, because I've got one in every term. And so if I pull that out, I get r squared plus 6r plus 9 equals 0. Well, I can just get rid of that e to the rx, right? Because if r squared plus 6r plus 9 equals 0, then the whole thing needs to equal 0. So now I just need to figure out what makes r squared plus 6r plus 9 equals 0. Well, if I factor that, that's a pretty easy factor. I get the solution r equals negative 3 twice. All right, so that means that our first part of our solution here, we've got multiplicity of 2, right? We've got negative 3 twice. So we know that one part of our solution is going to be y equals e to the negative 3x, but we need to have a second solution that is linearly independent, right? So I'm going to need to put an x in front. And I invite you to try this out, plug it back into the equation, see if it works, if everything cancels out correctly. There's no initial conditions here, so we'll just leave it in this form.